we're looking at here is a piece of 1045 steel, TG&P, which stands for turned, ground and polished. Now this is for the final two components of the crankshaft. Now PM Research give you a piece of 5/8 cold rolled steel for this, and it's, you know, it would work fine. It's a model after all. Well, it's a replica of a small engine. It would work, it would run, but rod always comes in. Rolled steel is never very round and it's never on size, it's usually undersized, and that was definitely the case with the piece they supplied. That's alright, it would have worked, but I do this kind of thing every day in my job as an engineer, and so I couldn't bring myself to use it, so I went out and bought a piece of this. Was going to turn down a piece of 3/4 inch, but I thought, no, let's get a nice piece of TG&P, and here's the bearings assembled onto their base, and you see that? That's a lovely fit. And that goes right through both bearings, no problem at all. Straight as an arrow. On it. Turns freely. So I know those two bores are aligned. So now I've made a slight change to the design. The crank webs in the design supplied by PM Research have 5/8 inch holes in them for a press fit on this. What I've decided to do, I've gone with 1/2 inch, and I'm going to turn the ends of this down. I'll cut two pieces from this, turn the ends down to give a shoulder to push up against. So pretty simple parts. I'm not putting a keyway in these like the drawings show, because I'm not using a keyed flywheel. I'm going to do a different thing there too, so we'll get to that. But so these are going to be fairly simple. Cut to length, indicate in my collet chuck, make sure they're running concentric, turn the shoulders, and then we can press the crankshaft. So look forward to that. Alright, join me at the lathe. Got a piece of this TG&P round bar mounted here, and I'm going to check run out, and I'm going to do it in two places. I've found the crown. There we are, right there. And so disengage the belt there. So we're right at 5/10 there. And we're the same there. So I feel good about that. I think 5/10 is a very reasonable number for this, so it doesn't surprise me that that's in, because I adjusted the chuck previously. This is a set true chuck, and I've clocked the face on here, and that there's no run out that I can measure there. So we're good to go. So let me get rid of this. Let's see if we can get to the crux of the matter. Now a little bit of high tolerance turning here. This has to be a press fit and can't overdo it or it will break the cast iron. I've measured the bore that we're pressing into, and that is 0.499. So I really want to turn the diameter on this to 4995 to 5005 at the most, and I really want to try and hit 0.5. on the money. So we will give that a go. Since this is a piece of carbon steel, I'm going to run coolant because that usually helps me get a reasonable finish. Bang on. So, final cut. Alright, 0.5 on the money. Alright. So now I'm just going to finish the shoulder and put in a little undercut. Good, so that just takes any radius out of that corner there, so this seats firmly. Next stage is just a little bit of a taper lean in. Here are the various parts. And first order of business is going to be to press the pin into one of the crank webs. Then what I'll do is use a gauge pin to align the center of the crank webs. Press the second crank web on. Then the crankshafts will go in. And what I will do is make a spacer, a close fitting spacer, to support the webs when I press the crankshafts in. So we can make a start. I've got this nice aluminium block there, or depending on which part of the world you're in. up. That's better. Just like that. Okay, set up with the gauge pin which slips freely through. Just like that. Whoops. Perfect. So now I needed about 4 hands to do that. However, as you can see, let's see if that's in focus. The crank pin is nicely in and the gauge pin slips easily through. So that is now perfectly in line. So, and this is where the story really starts. It's time to get the crankshafts in. Okay, continuing with the crankshaft assembly. I'm out in the outer part of my shed. This is where my welding equipment and my bandsaw and tyre changing equipment and kind of the grittier things are kept. Including this Carver laboratory press which came from a used store in Minneapolis. It's a gnarly looking thing, but it's a very nice piece of equipment. So I've got this set up now with a aluminum block, and actually let's go in and take a closer look. So I've machined a close fitting spacer so as to not bend the crankshaft assembly, and you can see we've got a nice aluminum block for that to sit on, and then another one at the top. Gently does it. There we are, look. That's exactly what you want, a nice gentle pressing in. There we are. Okay, here we go. Steady this. There we are. Nice and easy. Beautiful. So here's the completed crankshaft, and happy with this. This has come out very well, I think. And what I have here is the base assembly, and I'm going to give it a quick test fit. let's go for broke here. Let's not mess around. Let's get everything secured. Right away I'm very pleased because these caps have gone on without any issue at all. So, alright. There we go. Just a little sideways play, which is designed in. No play at all there, and easy and free to turn by hand. And this is completely dry, there's no oil in here. Maybe we should let's add a few drops. Silky smooth. There is a little tight spot there, but it's not bound. I wonder if there's a very slight misalignment of these shafts or something, but given that I can freely turn that with my fingers, I think that's great. I think that's a win. A lot of parts come together there. Wonderful. Starting to make some progress on this engine now. A few fiddly bits left to do. The flywheel, which I always leave to last, and it won't be too long, I hope, before we have this running. Anyway, thanks very much for following along again. Hope you get out to your own shop soon, make something really fun. As always, be safe, be well, wherever you are, and see you soon.